Hello, today we will be finishing 6.5 rhombi and squares. We talked a lot about these different properties and how we know whether a shape is a rhombus or whether it is a square. We also marked up our little chart, that is the first page in our packet, to help us out on our test coming up. Our last two questions that we have are example 3. So we are going to classify these shapes, whether they are rhombus, rectangle, or square. Now I want to point out to start with that these are already parallelograms. That's pretty important. If it was not already a parallelogram, we would first have to decide that it is a parallelogram before we decide whether it's a rhombus, rectangle, or square. So, since we already know it's a parallelogram, we can skip those steps. Instead, we're going to skip to deciding if this shape is a rhombus. And you are going to have to write kind of small. Now, one way you can decide if something is a rhombus is based on theorem 619, this one right here. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So we already know our shape down here is a parallelogram. Now I'm going to check if BC, segment BC, and CD are congruent. I could pick any two consecutive sides. Those are just the two that I picked. So is it a rhombus? Is segment BC congruent to segment CD? That's what we are going to try to answer. So I know that B is the point -1, 3. C is the point 3, 2. I am going to label x1, y1, x2, y2, because we are going to have to do the distance formula here, because we are finding out if they are the same length. So segment BC is, in our distance formula, y2 minus y1 squared plus x2 minus x1 squared. Notice this minus a negative becomes positive. We'll keep solving. We have -1 squared plus 4 squared. So this becomes 1 squared. 1 times 1 is 1, plus 16, or the square root of 17, which I'm just going to leave like that. Then I need to see, is CD the same length, or square root of 17? So we already know C is 3, 2. And D is, 2, -2. So I'm going to just label this x1, y1, because I'm now using these two, and C is already labeled x2, y2. You can label them how you want. You can completely rewrite them. I don't really care. We just need to use C and D, not B and D. So CD, I am going to have 2 minus a -2 squared plus 3 minus 2 squared. The minus and negative, once again, becomes positive. So I have 4 squared plus 1 squared. So that's 16 plus 1, or 17. Square root of 17, I should say. So guys, these are actually the same length. Segment BC is congruent to segment CD. So this is a rhombus by theorem 6.19. So we know it's a rhombus. Now we need to decide if this is a rectangle. I'm going to draw a little line underneath here. There are a couple ways we can decide whether something is a rectangle. We can check to see if these angles here are 90, or we can check the diagonals to see if they are congruent. For this problem, we are going to see if these are 90 and make sure that our slopes are perpendicular slopes. That's how we make sure that we have right angles. So we need some things to be perpendicular, like segment CD, maybe, must be perpendicular to BC. And CD must be perpendicular to AD. And then if CD is parallel to BA, we know that it is also perpendicular to the other two. So we're going to check the slopes of each of these. You could use your slope formula. For the sake of time, I'm just going to count, and we already have a picture. But if you want to use slope formula, that is the change in y's over the change in x's. That is totally an option. I'm just going to count. So my slopes for each of these, we have CD. I'm just going to rise from D, 1, 2, 3, 4, and then I run 1 to C. So my slope here is 4/1. Then I'm going to count the slope of BC. So from C, I rise 1, and I run left, 1, 2, 3, 4. So that is a -1/4 slope. So that checks out, guys. These are opposite reciprocals. You flip them, and you change the sign, and they are opposite reciprocals. So this one checks out here. They are perpendicular. This for sure is 90 degrees. Now let's check AD. We are going to rise from D and then run 1, 2, 3, 4 to the left. So it has a -1/4 slope, or 1 -4 slope. It does not matter which way you say it. So guys, this one also checks out. These are perpendicular here, because these two are opposite reciprocals. Then we need to check our last slope of BA. We rise 1, 2, 3, 4. We run 1. That is a 4/1 slope, making these two parallel to each other. So, because these two have the same slope and they are parallel lines, we have a theorem that we learned quite a long time ago that means that these are also perpendicular. So guys, because of these slopes, we know that we have a rectangle. So, I'm going to write a similar question as we had above. The question is rectangle. And what we're trying to answer are the sides perpendicular, and the answer to that is yes. By checking the slopes for perpendicular, we have a rectangle. Now here's the deal, it also has square as an option. Guys, because this shape is both a rhombus and a rectangle, it is a square. So we're going to write that down. So since it is both a rectangle and a rhombus, it is a square by theorem 6.20. And that's our answer. Lots of steps to get there. We had to check our shapes out for rhombus and rectangle, and then decide it is a square. The U-try is really similar. Go ahead and pause me, try it out. You can use these methods. I'm going to use different ones when I go through it. There are other ways that you can figure these things out too. Okay, so I went ahead and wrote some things down. For our rhombus, I want to ask this time, are our diagonals perpendicular? If I were to draw GEN and FHN, are these crossing at 90 degrees? If they are, by theorem 6.17, we would have a rhombus. So I went ahead and I started writing these out. We are going to actually use the slope formula this time, just so you can get practice with it. You could also just count as well if you want to check that way. Either way, for GE, I have these points right here. I am going to plug them into the slope formula that I wrote up here. So we have -2 minus 3 over 0 minus a -1. This gives me -5, over 1, which means my slope for this is just -5. Now, I need to make sure that these are perpendicular to each other, so I am going to find the slope of FH now, or HF, by plugging in its numbers. So I have 0 minus 1 over -3 minus 2. This is a -1 over -5 slope, which becomes 1 over 5 when I reduce or get rid of those negatives. And guys, -5 over 1 and a 1 over 5 are the flipped version of each other and the opposite signs. So this does check out. We do have a rhombus. Yes, by theorem 6.17, it is a rhombus. The diagonals are perpendicular to each other. All right, I'm going to pause and write out some rectangle stuff. Okay, for a rectangle, you can check to see if the diagonals are congruent. If the diagonals are congruent, by theorem 6.14, we know that that would be a rectangle. Reminder, we can only do this stuff right away because we already know it's a parallelogram. We don't have to decide that first. So, unlike the last problem where I checked the sides to be perpendicular, you could do that too, I am checking the diagonals length. So we are going to use the distance formula here. We have y2 minus y1 squared plus x2 minus x1 squared. This gives us, oops, did not need that, -5 squared plus 1 squared, or once you finish solving, 25 plus 1. Reminder, -5 times -5 is 25, not -25. So this is the square root of 26. If you wanted to round this, it would be about 5.1, or you can just keep it and compare with the square root 26. Now I'm going to move on to FH, or HF. I already have the points written down over there. So we have y2 minus y1 squared plus x2 minus x1 squared. We have -1 squared plus -5 squared. So we have 1 plus 25, or square root 26, which once again is about 5.1. So these diagonals are the same length. So we can say the answer to our question, are the diagonals congruent? Yes. So by theorem 6.14, it is a rectangle. And guys, this is really similar to the first one we did together because this is a rhombus and a rectangle, so this shape is also a square. If it was not both, if this, say, was not congruent diagonals, then it would not be a square, it would just be a rhombus. All right, and that does finish up the notes for today. So make sure you get those written down, and I'll see you soon. Bye.